Okay, so this is problem 11 on the 2020 AMC 10B. So Miss Carr asks her student to read any 5 of the 10 books on the reading list. Harold randomly selects any of 5 books from this list, and Betty does the same. What is the probability that there are exactly 2 books that they both select? And there are 5 options: A, B, C, D, E. Okay, so this problem might seem a little complicated at first because you're going to be like, okay, so I have to figure out how much ways Harold can select 5 books, and I have to figure out how much ways there are 5 out of 2 books. There are 2 out of 5 books in which Harold and Betty have in common, and I want to figure out how much probability, how much number of combinations Betty's book from the book list can be. Okay, so let's just do that. So let's just try to figure this out using our way. So Harold randomly selects 5 books. Okay, so there's 10 choose 5 ways to this action. Then we want 2 books to be in common. So we have 5 choose 2 ways to accomplish this. So 5 here is the 5 books that Harold already chose from his book list. Okay, so now Betty has to choose the 2 books here that are in common to be in common with Harold. So Betty has another 8 choose 3 choices to make for our other 3 books out of the 8 books available, because the 2 books there are already in common. So actually, no, wait. So she has a choice she has a choice out of 5 choose 3 books. So the reason here is because we already have 5 books chosen. So Betty chooses any of, and we have 2 books in common already. So if Betty chooses any other out of her 3 books, any other book out of her 3 books are the same as any of the 5 books out of the 10 books, then there will be 3 books or 4 books or even 5 books in common between Harold and Betty's book list. So that's not our requirement. So we can only choose from the 5 books which aren't chosen by Harold. Okay, so let's just compute that actually. Let's just compute that firstly. So we have 10 times 9 times 8 times 7 times 6 over 5 times 4 times 3 times 2. And then we have 5 choose 2, which gives us 5 times 4. So 5 times 4 over 2. Okay, and then we have 5 choose 3, which is equal to 5 choose 2. So that's also 5 times 4 over 2. So we can just try to cancel factors out from this. So we have 8 and 4 times 2. We have 5, 10 gives us 2. We have 3 here, which we can cancel off 6 to give us 2. We have 4 to cancel, so that's giving us 2. We can cancel 4 and 2 to give us 2. So we can simplify this to 2 times 9 times 7 times 2 times, so 5 times 2 is just 10. So, and we have that 2 times, so we have 100. So this value here times 100. So we have 18 times 14 times 100. Okay, so we can do some long multiplications. We have 18 times 14. So 4 times 8 is 32. 1 times 4 is 4, plus 3 is 7. 1 times 8 is 8. 1 times 1 is 1. So we have 2. So 72 plus 180 is equal to 2. 7 plus 8 is 15. 1 plus 1 is 2. So we have 72 plus 180 is 252. Okay, so our answer to 18 times 14 is 252. So this answer here is going to be 252 times 100, which is just 25200. So for 25200, this is the number of cases where Harold chose 5 out of 10 books from the provided 10 books recommended, and then Betty chooses 3 books out of the 5 books that Harold hasn't touched yet. And then Betty also chooses 2 books out of the 5 books that Harold has already chosen, so that they have exactly 2 books in common. Okay, so we have 25200 cases for this. So for probability, it's actually just equal to the number of total cases, the number of desired cases, which is 25200. So these are the cases we're happy with, over the number of total cases. So now we want the number of total cases. So what's this? The number of total cases is just going to be 10 choose 5 times 10 choose 5. So why is that? So basically the number of total cases is basically just, we have Harrow to choose 5 books from the book list. And then Betty chooses 5 books, disregarding whatever Harrow chooses. So they're not related, they're independent events. So this provides us with all the combinations that Harold and Betty might choose. Okay, so we have 10 times 9 times 8 times 7 times 6 over 5 times 4 times 3 times 2. And we square this value here. So we just cancel this out. So we have times 8 times 4 times 2. We have times 3, which gives us times 2. If we cancel out with times 6, we have 5 and 10, which gives us 2. So this is equal to 2 times 9, which is 18, times 14, which is 252 squared. Okay, so we have 252 times 100 and 252 times 252. This just gives us, we can cancel out the factor of 252 here. So that gives us 100. We have 100 over 252. If we just divide this by, if we just divide the denominator and numerator by 4, we have 25 over, so we divide this by 4, we have 4 times 6, 24. So we have 63, so we have 25 over 63. And that indeed is our answer, and it's also one of our option choices, so we know that we're not wrong. So we choose D as our answer. Okay, so this is our answer to this problem, and the key takeaway in this problem is that we need to figure out how we count the number of desired cases. So this is just basically Harrow chooses 5 out of 10 books randomly, and then Betty chooses 2 out of 5 books that Harold already chose, so they have 2 books in common. And then Betty chooses 3 out of 5 books which Harold hasn't chosen yet, so they don't have more than 2 books in common. And then we have that over the total number of cases, which is just 10 choose 5 squared. So thanks.